In these challenge questions, we're bringing together everything from the skills so far in this unit. So you want to make sure you're really confident on those previous skills before attempting this one. So in this question, we're given some trials for different initial concentrations of each reactant and told the initial reaction rate. Based on that, we're going to figure out the order of the reaction with respect to each reactant. We're going to figure out the differential rate law for this reaction. We're going to figure out what a reaction rate would be based on a fourth trial of possible initial concentrations. And we're going to figure out what our graphs would look like for initial rate against initial concentration for each reactant. So let's get started. In this question, we're told we have a fictional reaction with substances ED and XA. So you can see in our chemical equation, we've got 2ED plus XA reacting together. Okay, the scientist conducts multiple trials with different initial concentrations of each reactant and measures the initial reaction rate as shown in the table provided. So that's trials 1, 2, and 3. We're given the initial concentrations and the initial reaction rate. Our goal is to figure out the order of reaction for each of those. So we're going to use the same method that we used in the previous skill where we just practiced this one thing. So let's start by figuring out what the order of reaction is with respect to the concentration of ED. So I'm looking for two rows in my table that have different values for the concentration of ED, but the same value for the concentration of XA. So I'm going to be looking at rows 2 and 3, since we can see the concentration of XA is the same there. Now I'm going to start by looking at row 3 and seeing what the change was to row 2. So I started out with an initial concentration of 2.3. I ended up with an initial concentration of 6.9 in trial 2. So 6.90 divided by 2.30, that gets me 3. So I know that to get from trial 3 to trial 2, the initial concentration of ED multiplied by 3. So now I want to figure out what was that effect on the initial reaction rate. So we know that it went from 0.02 to 0.54. So I ended up with 0.540. I started with 0.0200. That ends up getting me 27. Our reaction rate times by 27. Okay, so if my initial concentration of ED multiplied by 3, my reaction rate multiplied by 27. 27 is 3 to the power of 3, because 3 times 3 times 3 gets us 27. So that's telling us our order of reaction for the concentration of ED is 3. It's third order. Okay, great. Next step, finding the order of reaction with respect to the concentration of XA. So for this one, I'm looking for two rows that have the same value for the concentration of ED, but different values for the concentration of XA. So that's going to be row 1 and row 3, because we've got the same value, 2.3, for the concentration of ED, but we've got a different value for XA. I'm going to start at 2.3 in trial 3 and look at the change to trial 1, where I have 9.2 for my concentration. So my change there is I ended up with 9.20 molar for my concentration of XA. I started out with 2.3 molar. That is a change of 4 multiplied by 4. So from trial 3 to trial 1, my concentration of XA multiplied by 4. So let's figure out what happened to our rate. Our rate ended up at 0.0800 and it started at 0.0200. That's 4 as well. So my initial concentration of XA multiplied by 4, my initial reaction rate also multiplied by 4, which is 4 to the power of 1. It's just 4. So my order of reaction is going to be 1 for XA. Okay, great. So we've done the hardest part, figuring out our order of reaction for each reactant. To find the overall order, we just need to add those up. 3 plus 1 gets us 4. So our overall order of reaction is 4. Okay, next we need to write our differential rate law. So remember, to do that, our rate is equal to K, which is going to be the rate constant, multiplied by the concentration of each reactant to the power of the order of the reaction with respect to that thing. So the concentration of ED to the power of its order, which is 3, multiplied by the concentration of XA to the power of its order, which is just 1. And remember, anything to the power of 1, it's just the number itself, so we can get rid of the 1 there. So let's go ahead and find that option here. It's ED cubed and then XA. Awesome. Okay, so we've got our rate equation. Next step is finding our rate constant. So we're going to be putting in our numbers from one of our trials to figure out what K is. So first I'm going to rearrange my equation to get K on its own. So I'm going to divide by ED cubed and XA on both sides. That's going to give me K equals rate divided by the concentration of ED cubed multiplied by the concentration of XA. So we need rate, concentration of ED, and concentration of XA. We have 3 options here. We could use any of those and we should get the same value. So you can just pick one. So I'll pick the first one and put in my numbers. So my rate is 0.0800 divided by the concentration of ED, which is 2.30, and that's cubed, multiplied by the concentration of XA, which is 9.20. If we put that in our calculator, we're going to get a rate constant of 0.000715. So let's check that to make sure we got that right. Awesome. Okay, so we know the rate constant. We still need to find the unit for the rate constant. So to do that, I'm going to just substitute in my units into my equation. So my units for rate are molar per second. And then I've got my units for the concentration of ED, which is molar, and that's cubed, multiplied by my units for the concentration of XA, which is molar. Okay, now I'm going to rearrange that to make it look a little clearer. So I'm going to have molar on the top, and then on the bottom, I've got seconds, molar cubed, and molar. The molar on the top is going to cancel with one of the molars underneath, and we're left with 1 divided by seconds times molar cubed. And that's for our units. So our unit here is going to be per second molar cubed. Awesome. Okay, we've done most of the work. Next, we need to complete the table with the expected initial reaction rate for trial 4. So in trial 4, we're given the initial concentration of ED, the initial concentration of XA, and we're trying to find the initial reaction rate. So we've got 2 options here. One option is to do it using ratios by seeing, comparing with trial 2, our initial concentration of ED is the same, but our initial concentration of XA has changed. So we could use that along with the order of reaction to figure out the reaction rate. Our other option, now that we know K, is just to put our numbers into our reaction along with K to calculate the rate. That's going to be quicker, so I'm going to choose that method, but either one will work. So we're going to have rate is equal to K, where K we've calculated is 0.000715. That gets multiplied by the concentration of ED cubed. Concentration of ED is 6.90, and that's cubed. We're multiplying that by the concentration of XA, and that's just to the power of 1, so just itself. So that's it. If we put in our numbers here for the rate, I'm going to get out 2.16 molar per second. Let's check that out. Awesome. So that's a super quick way of doing it. Equally, we could have used the ratios method and gotten the same answer. Awesome. Okay, final step is finding our graphs of initial rate against initial concentration for each of our reactants. So ED is third order. Remember, third order is cubed. So it gives us this kind of harsh, kind of steep curved graph, which is our cubed graph. So that's going to be graph 6 for ED. Let's check that. Awesome. And then for XA, it's first order reaction. First order is a straight line graph because it's directly proportional. So that's going to be graph 4. So as you can see, this question brings together everything from our previous skills so far. So firstly, we're using the table and the ratios method to figure out the order for the reaction with respect to each of our reactants. We're using that to find our differential rate law. We're plugging in some numbers from our table to figure out our rate constant and unit. We're then using that to figure out what the initial rate would be in a fourth trial. And finally, we're using our order of reaction for each of our reactants to figure out what would the graph of reaction rate against initial concentration look like. So lots of steps there, lots to deal with. Make sure you're confident on the previous skills before attempting this one, since it brings all of those previous skills together.